We will have to rewrite our textbooks. How the James Webb Space Telescope is reshaping our understanding of the universe. Everyone has been waiting for this one image, and it's changing everything. We will have to rewrite our textbooks on the beginning of the universe. Dr. Michio Kaku, theoretical physicist. A cosmic upheaval. For decades, our understanding of the cosmos has rested on a sturdy foundation of theories, carefully tested, revised, and taught to generations. Central to this structure is the Big Bang theory, the idea that the universe began as a singularity some 13.8 billion years ago, expanding outward into the vast expanse of time and space we see today. That model, alongside laws of physics, planetary formation, and the nature of stars, formed the bedrock of astrophysics. But now, in what may be the greatest scientific upheaval of the 21st century, those very foundations are shaking. Since its launch, the James Webb Space Telescope has delivered one jaw-dropping discovery after another. Originally intended to confirm and refine existing theories, Webb is doing the opposite. It's demolishing many of our cherished assumptions. The telescope's extraordinary resolution and powerful spectrometry are revealing a universe that is older, stranger, and far more dynamic than anyone could have predicted. We are witnessing what Dr. Kaku refers to as the beginning of a new era in science, one where the answers we thought we had are now questions again, and the universe seems less like a solved equation and more like a beautifully complex mystery. The galaxy that shouldn't exist. Let's begin with a discovery that sent shockwaves through the scientific community. Source: 2112, a galaxy observed by Webb that appears to be a near-perfect twin of the Milky Way. The problem? It existed when the universe was supposedly only 1.5 billion years old. According to our best models, spiral galaxies like the Milky Way, large, organized, rotating structures, should take billions of years to form. Yet CERS 2112 appears fully evolved far too early in the cosmic timeline. And it's not alone. JWST has discovered over 1,600 disk galaxies from the universe's earliest epochs, just a few 100 million years after the Big Bang. These galaxies are not the messy, irregular clusters we expected. They are stable, well-formed, and alarmingly mature. This leads to an inescapable conclusion. Either galaxies formed faster than we thought possible, or the universe is much older than we currently believe, or the Big Bang model itself is fundamentally flawed. The age of the universe, 13.8 billion years or 26.7. One of the most provocative voices in this unfolding drama is Dr. Rajendra Gupta, a physicist at the University of Ottawa. He has proposed that the age of the universe is not 13.8 billion years, but 26.7 billion years, nearly twice as old. Gupta's hypothesis addresses the growing number of impossible galaxies and anomalies observed by JWST. His model reinterprets how the universe expands, introducing modified gravity, an evolving form of dark energy, and even revisiting the long-dismissed, tired light theory proposed by Fritz Zwicky in the 1920s. If Gupta is correct, then these ancient galaxies aren't paradoxes. They had plenty of time to form. His model may also explain other long-standing mysteries, like the conflicting measurements of the Hubble constant, a tension that current cosmology has failed to resolve. Despite skepticism from mainstream astrophysics, Gupta's recalculation has become impossible to ignore in light of Webb's discoveries. Exoplanets that break the rules. It's not just galaxies that are defying expectations. Planets themselves, particularly those orbiting distant stars, are also rewriting the rulebook. KLT 9b, the planet that shouldn't exist. This ultra-hot Neptune-like exoplanet orbits its star so closely that its atmosphere is being blown away by stellar radiation. Temperatures on KLT 9b are so extreme that water molecules split into atomic hydrogen, something once believed to occur only in stellar environments. The physics of this world defy classification. It's as if the planet exists in a transitional state between a planet and a failed star, a realm we never even theorized. WASP 76b, a planet where iron rains from the sky. Another planet, WASP 76b, rotates with one side eternally facing its star. On the day side, temperatures soar high enough to vaporize iron, which then condenses and rains molten metal on the night side. These kinds of chemical cycles weren't just unexpected, they were unthinkable. Retrograde worlds and planetary anarchy. Then came planets like WASP 17b, orbiting their stars backwards, in the opposite direction of the star's rotation. This retrograde motion challenges our very model of planetary formation, which asserts that all planets form from a rotating protoplanetary disk and thus share a common direction of orbit. The current theories can't explain these renegade worlds unless we invoke gravitational chaos, rogue stars passing through systems, or multi-planet brawls that eject some worlds and flip others upside down. Wanderers of the cosmos. Planets without stars. One of the most baffling revelations from JWST is the existence of rogue, or vagabond planets, massive, starless worlds that drift alone through space. In the Orion Nebula, Webb discovered 80 such objects, many of which exist in binary pairs, planets orbiting planets, without any star to anchor them. This discovery is unprecedented. It's the planetary equivalent of a solar system forming without a sun. Some of these objects may actually be brown dwarfs, a kind of failed star, but many exist in a mass range that sits uncomfortably between planets and stars, defying categorization. The dwarf planet that defies expectations. Closer to home, Webb has also focused its gaze on the Kuiper Belt, a ring of icy bodies beyond Neptune. Among them is 2007 or 10, a dwarf planet that is dark red in color and rich in complex organic molecules known as tholins, potential precursors to life. Yet this planet remains unnamed and poorly understood, partly due to its weird orbit and extreme distance. Its presence hints that organic chemistry may be more common in our solar system than once believed. Science in crisis, or science evolving. The scientific community is grappling with these discoveries. For the first time in generations, we don't have a framework that adequately explains what we're seeing. Dr. Michio Kaku put it plainly. Right now, there are more questions than answers, and that's okay. It means we are standing on the threshold of discovery, in a place where the universe is no longer just a set of numbers in a textbook, but a living, evolving enigma. We may have to rewrite our textbooks, as Michio Kaku suggested. But perhaps more importantly, we will have to rethink what it means to know anything at all. Stay curious, because the universe is just getting started.